The purpose of this video is to go over U3L2, the simplest set of naming rules, the beginnings to naming chemical compounds. So in order to do well at this, you're going to need two things. You're going to need your polyatomic ion list, and you're going to need a periodic table, and you're going to need some of that we labeled in the previous lesson. Okay, so let's start here then by reviewing some things that we're going to need as prior knowledge. So first of all, identify the following as a metal or non-metal. So hopefully we remember that there is a dividing line on the periodic table, and that on the right of that line are non-metals, on the left are going to be the metals. We did identify some in a transition zone that we called metalloids, but for the purpose of nomenclature, anything that is on the right side of that line, you're going to name as with the rules for covalent compounds. And if it is on the left side, the cation is on the left side, then that's going to be a metal, even if you would normally call it a metalloid. Okay, so the first one is lithium. And we see that lithium is over in group 1A, so that's definitely a metal. The next one is gallium. Gallium is here, so anything that's on the left side is a metal. The next one is hydrogen. We said that we always have to remember that even though hydrogen is over here on the left side of the table with metals, hydrogen is certainly not a metal. And you just always have to remember that. So even though it's on the left side, we want to remember that hydrogen is a non-metal. Okay, phosphorus is here, so phosphorus is going to be a non-metal also. Aluminum is here on the left, and so aluminum is a metal. And boron sits here, but it is going to be considered to be on the right side of that table, and so we're going to say that boron is a non-metal. Okay, the next one says, do each of the following form cations or anions? So remember that the word gives us a clue as to the meaning. We said we could use a little mnemonic, that the T in cations was going to remind us that those were positive ions, and the N in anions was going to remind us that those were negative ions. Okay, so are these going to form positive or negative ions is the question. So we see the first element is calcium, and so we find calcium. Metals form positive ions. Everything in group 2A, the alkaline earth metals, will always form a positive 2 charge when combining with nonmetals. So positive ions are cations, so we're going to say it's going to be a cation. And the symbol with the charge, whenever it ionizes, the symbol would be Ca2+. And then the name of that ion, we would call that a calcium ion. Okay. Oxygen. So we find oxygen located on the right side of our dividing line, and oxygen is a non-metal, and when it combines with metals, it takes on a -2 charge. So we're going to say -2 would make it an anion, and the symbol with the charge would be O, and then 2-. And then the ion name, unlike the cations, where we just use the same word, if the element was calcium, it's just a calcium ion. For anions, for negative ones, we change the ending to IDE. So we would call it not oxygen, but an oxide ion, or just oxide. And it doesn't hurt to put the word ion there, but it's often, you're going to, when we do nomenclature, the word ion generally will not follow it. Bromine, if we look at, for bromine on the periodic table, it's here. So we're going to say that's going to be on the negative side, so it's going to be Br. And everything in the halogens, which includes bromine, takes on a -1 charge. when combined with metals. So we're going to call that an anion. And it would be a bromide ion. Okay. Next, reading a formula. So we're going to start seeing formulas that look like this quite frequently, where we have both large numbers called coefficients written in front and small subscripts written behind. All right, if you see a large coefficient in the front, it means you have 2 of everything behind it. If you see a 2 written as a subscript, then that's telling you you have 2 hydrogen that are chemically joined together or bonded together as a unit. So writing something like this would mean you had 1 hydrogen atom. If you put a 2 in front of it, you have 2 separate hydrogen atoms. But if you write it H2, then you have a hydrogen molecule. That implies that these 2 things are joined to form 1 unit. If you put a 2 in front of this, then you have 2 hydrogen molecules. So just going over what the numbers are going to mean in terms of coefficients and subscripts. So if we look at this first one, and it says how many atoms are represented. So if I count up how many atoms there are present, I would say 1 of these and 2 of those. So altogether there are 3. How many atoms are here? Well, there are 3 in each one of these molecules, but I have 3 molecules. So altogether I would have 9 represented by that terminology. This one, I have 1 plus 1 plus 1 plus 3. So that's 6 atoms that are combined. And now it's saying I have 2 of those. So that would be a total of 12. All right, on this one, if you have parentheses, then you have 2 of everything in the parentheses. So I like to add up the parentheses, so that's 1 plus 3 is 4. 4 atoms making up this polyatomic ion in the parentheses. So then I would say 2 times 4 is 8, and then this one is not in the parentheses, but we still add in 1 more. So 4 times 2 is 8, plus 1, we would have 9 atoms represented by that terminology. Now, if we had a 4 in front, then we'd have 4 of those. If each one is 9, then that would be a total of 36 atoms represented. Okay, naming rules. Covalent molecular covalently bonded compounds for molecules. So these are going to be the naming rules for things that are composed of 2 nonmetals. So if both of the elements are from here, and often hydrogen is one, remembering hydrogen is also a nonmetal, then we're going to use a set of rules that involve using Greek prefixes to indicate the number of atoms of each element present in the compound. So the Greek prefixes are pretty much the same ones that you use in your math class. I think this on your sheet says hepta. So I think hepta for 7 is one. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Those are the prefixes. We're going to use those, just like if you had a 6-sided figure in math, you would indicate that by saying hexagon. We're going to say that we have 6 chloride ions by saying hexachloride. So we're just going to use it to tell how many that we have. Mono means 1, but if you only have 1 of the first element in the compound, then you leave the word mono off. You change the ending of the last element to IDE. You do not try to add up charges. So there are no charges on these. These are not ionic, they're molecules. So no trying to sum the charges. So if we try to name this first example, P3O5, so we look for the first element, and when we decide that the first element is a nonmetal, the second one is going to be a nonmetal for sure. So we know that we have 2 nonmetals, so we're going to use Greek prefixes and tell how many of each we have. So the first word we do not change at all except to add the prefix. So it's going to be triphosphorus. And then we want 5 oxygen, so it's going to be pentaoxide. And on that one, I would end up with, don't write it just yet, I would end up with something that looked like this, pentaoxide. And generally, if the A and the O end up together like this, the A is omitted. So we're going to write a space, it's a separate word, and now we're going to write pentoxide. And notice I changed the ending on oxygen to IDE. We want to switch the ending to IDE. So triphosphorus pentoxide. The next one, CO2, I think we all know what that one is. I am not going to say there's one carbon, but I am not going to say monocarbon, because generally the word mono is omitted from the name of, if it's one of the first element, we don't say mono. So we're just going to say plain old carbon. And then 2 oxygen would be dioxygen, but we change the ending to IDE, so it becomes dioxide. The next one, we have 2 of the first one, so we're going to say dinitrogen. Notice you do not put an IDE on the first word, just dinitrogen. And now I'm going to say 1 oxygen. So I'm going to say mon, and we're not going to put M-O-N-O-O like monooxygen. We're going to just use 1 O. So monoxide. And change the ending to IDE. So dinitrogen monoxide. The formulas for the above compounds represent one blank. If everything is a nonmetal, then we form a kind of bonding called covalent, meaning they share electrons, and the smallest unit is represented there, which would be 1 molecule of that compound. Okay? Now, what about if it's not 2 nonmetals? What if it's a metal and a nonmetal? Then that's going to be an ionic compound. Electrons are going to be transferred, gained, and lost. Something's going to become positive, something's going to become negative. So they are composed of the positive metal ion and the negative non-metal ion. Notice that the ammonium polyatomic ion can substitute for the metal. So that's the only positive polyatomic ion you have is ammonium. And since metals are positive, you'll always have a metal in front unless you see this group, and then you're going to recognize that as your cation. So the rules are pretty simple. The cation is always put first. So it's always going to be the positive in front and the negative behind when you write your compound. A simple cation takes its name from the name of the element. For example, a sodium ion is just called sodium in the name of the compound. A simple anion is named by taking the first part of the element name, the root, and adding IDE. For example, Cl- is called not chlorine but chloride. Names of polyatomic anions or cations are not changed. You don't put IDE on them. For example, this is a chlorate polyatomic ion. You would know that because it's on your list. So the sooner you memorize this list or become really familiar with it, the better off you are, because then you can recognize when things are on it. So this is a chlorate ion, and you do not change the name of that. It would remain chlorate in the name of the compound. So let's practice a couple of them. So first of all, you just name the metal without changing anything. So it's just going to be magnesium. And then this back part, if you have been studying your polyatomics, you might recognize that as this. That is hydrogen carbonate or bicarbonate. You can use either term. They mean the same thing. So I'm going to use, I'll put hydrogen carbonate this time. Notice I did not change the ending to IDE, hydrogen carbonate, because it's a polyatomic ion. You're going to never change the name of a polyatomic. And I ran out of room, but carbonate should be sort of squeezed in there. Okay. The next one, okay, rubidium is a metal. Now, I am not going to say dirubidium. If it's an ionic compound, you never use Greek prefixes. The only time you use Greek prefixes is when both of these are nonmetals. So if one of the elements is over here, just one of them is a metal, you never use the Greek prefixes. So this is not going to be dirubidium. It's just going to be rubidium, no Greek prefix. So rubidium, and then I want to say, I'm not going to, no Greek prefixes, no mono, it's just going to be oxide. So again, I cannot tell you this enough. Very common mistake for students to make is try to put those Greek prefixes on an ionic compound. Only use the Greek prefixes on molecules, not on things that are ionic. This would be a formula unit. So I'm just going to name the metal calcium. And I am not going to say di. That's a Greek prefix. I'm just going to say I'm going to change chlorine to chloride. The next one, I'm going to notice this as being the ammonium polyatomic ion. So I've got ammonium, and then SO4 is another polyatomic ion. It's sulfate. So I'm going to write and never change anything about the name of a polyatomic. So it's just going to be ammonium, and then sulfate. Okay. The formulas above represent one. These are ionic compounds, and so we talk about formula units. And we discussed that in the last lesson. So each of these would represent one formula unit of that compound. All right, so then it's very important to note that in the formulas of ionic compounds, simple ions are written as element symbols. So Cl in this compound means a chloride ion, and that's why we put chloride at the end. And Na means a sodium ion, or Rb means a rubidium ion. So what we're saying is you don't write the charges internally, like you're not going to show the charges, but it's understood that those are actually ions because it's an ionic compound. However, whenever they dissolve in water or come apart and you show them individually, then you do show them with their charges attached. So like calcium written inside the compound, it's still an ion, but we don't show the charge. But if we were to separate the ion, it dissolved, or then we would say this is a calcium ion with a 2+ charge, and this is an oxide ion with a 2- charge. All right, particle sketches. We do want to be sure that we're up with how to do particle sketches of these. So name each one of these. So we're going to look at the first element and see that the first element is a non-metal hydrogen. Even though it's over here, it's a non-metal. So that means we're going to be using this set of naming rules with the Greek prefixes. So we're going to say, how many hydrogen? 2. So that's the prefix di. So we're going to say dihydrogen. And then we want to say 1 oxygen. So monooxygen, but we're going to take one of the O's off, so monoxide, and change the ending to IDE. Dihydrogen monoxide is the scientific name for water. Make a particle sketch. For us in this class, for this year, we're always going to use just an empty circle for oxygen. There are a lot of oxygens in chemistry, and it looks funny if you try to put an O inside an O, it looks confusing. So an empty circle will always represent oxygen. For hydrogen, we have to draw a lot of hydrogen also. So a hydrogen for our class is just going to be a little tiny colored in dot. Hydrogen is our smallest atomic radius, so I think we're justified in making it really small. So that would be our water molecule. Mine looks a little funky. Okay. Now, name this one. Label each as representing a molecule or a formula unit. So we'll do that at the bottom. So this one is magnesium is a metal. If it's a metal, then we're going to use these rules. So we're going to name it, just name the cation, then the anion, and change the ending to IDE. We are not going to use Greek prefixes, no matter how tempting it may look. So this is just going to be plain old magnesium. And then not chlorine, but chloride, and certainly not dichloride. That would be Greek, and we don't put Greek prefixes on ionic things. So magnesium chloride. And then to draw our particle sketch, we're going to think in terms of this, all right? So I'm going to have one magnesium ion with a +2 charge. So I'm just going to put Mg, and it's going to have a charge of 2+. And just for convenience sake, I'm going to put it in a little bubble since I'm making a particle sketch. And then I'm going to have 2 chloride ions. So here's my first one with the Cl. And now you might ask, should we draw the other Cl like in a line over here? Well, let's make it as accurate as possible. We know that opposite charges attract and the same charges repel. So 2 chloride ions would want to stay as far apart from one another as possible, but they would both be attracted to the positive magnesium ion. So let's put it on the other side like that. All right, so when we sketch them, we show the charges. All right, the next one has a polyatomic ion. It's calcium hydroxide. So we know this is an ionic compound because it has a polyatomic ion in it, right? So, and it also has a metal. So we're just going to say calcium, no Greek prefixes, unless it's part of the polyatomic's name. So calcium, and then this is hydroxide, not dihydroxide, just hydroxide. All right, that is the name of the polyatomic ion. And if you're wondering how we knew that, because it's on our list right here, OH minus is hydroxide. All right, now that little 2 is telling us we have 2 of those units. So let's see how we're going to draw this one now. First, we'll start with the central atom. The metal, everybody's going to be attached to that metal. So calcium 2+ is going to become our central ion. And now when we write a polyatomic ion, I'm going to have us to write that ion in brackets like this. And we've got an OH would be an oxygen. Remember, that's just going to be an empty circle, and a hydrogen, which is going to be a little colored in sphere. And this whole piece right here is going to have a -1 charge on it. So you can either put that inside or outside. I'm going to put mine out here. Now this little 2 right there tells me I have 2 of those. So I need to put another one over here. And my oxygen, and there's my little hydrogen. And I need to put my charge on the outside. So I have 2 -1 charges and 1 +2 charge. And that's going to be what it looks like. When each of these dissolves in water, how many ions will form and how many total atoms are present? And so if we do the first one, how many ions form? So are you thinking to how many ions do I get out of that? Well, you actually do get some, we'll see in the spring, but it's such a tiny, tiny fraction that we're for right now going to say 0. For right now, we're going to say it's actually like 10 to the -7th molar of both. Anyway, we'll just leave it right now at 0. And then it says how many total atoms are going to form, or how many total atoms are present. So there's one molecule that's made of 3 atoms. The next one says how many ions form when this dissolves. Well, when it dissolves, it would come apart the ionic bonds between here and here would break. So it would come apart into 1 magnesium and 2 chloride. So altogether we would get 3 ions forming, and we would also have 3 total atoms. On this last one, how many ions would form? These covalent bonds, the shared electrons between nonmetals, do not break when it dissolves, so this holds. So this is going to stay together as one piece, and that's why we put it in brackets like that. And that's so the whole thing, this stays together. So we'll get 1 ion, 2 ions, 3 ions. But how many atoms do I have altogether? I have 1, 2, 3, 4, 5 atoms in total. Now the only thing we missed was we were asked to say which one of these is a formula unit and which is a molecule. So if you're using Greek prefixes, that is a molecule, and the abbreviation for that for us this year is MCl, molecule. If you are showing charges, that makes it ionic. No Greek prefixes. Ionic compounds do not form molecules. We count them in terms of formula units. So formula units is our abbreviation. All right, so that concludes this little quick review of simple naming rules. Thank you for being here.